Good morning, students. Good morning. Structure of atom. Okay. So we were discussing about the structure of atom. Fine. Okay. So anyone, what we have discussed in the last class? Any one of you? Yes. Good morning. Any one of you can tell me what we have discussed in the last class? Yes. So still students are coming. Okay. Bohr's atomic model. Very good. Yes. Which is very important. So we have discussed about Bohr's atomic model. Okay. So B should be capital. Anyway, you have written in the message. I'm not worried about that one in the exam. Okay. So that's where we have the Bohr's atomic model. Yes, all of you are right. Now when it comes to Bohr's atomic model, first what we should write? We should write that it is based on the hydrogen spectra, right? That should be your first sentence. It is based on the hydrogen spectrum. Then what we have to write? Then we have to talk about different postulates. Minimum 4 points should be there. Minimum 4 points should be there. So first we have to talk about orbits. I am not writing in detail. We have to talk about orbits. Okay. So yes, Dikshit. So first we have to talk about orbits. So what do you mean by orbits? Orbits are nothing but it is an energy level. Okay. So it is based on the hydrogen spectra. Yes, Rohan. Then we have to give the postulate. Minimum 4 postulate. You can decide based on the marks. If it is for the 3 marks, minimum 3 points you have to write. If it is for 4 marks, minimum 4 points you have to write. Okay. So more than that, no problem, but it should not be less than that. So depending on the marks. So normally it will be asked for 4 marks only if they are asking. Okay. First we should talk about fixed path for the electron, which is called as orbits, and you should underline the word orbits so that evaluator should focus on those particular words and he or she will decide, okay, this boy or this girl, they know the concept and they will give the marks. Okay, so that's how you should write the answers. Answer script should be maintained like that. Okay, that's where we have the orbits. Then we have to talk about no change in the position. No change in the position with respect to electron, with respect to time. No change in the position until unless external force or energy has been applied or energy has been removed. Only during that time there can happen, this can happen. All of you have understood? So that's where second point will be. What I mean to tell here is these points should be first, these points should be second. That is not compulsory. Position of those postulates can be here and there, but minimum those many points should be there. That's all. Then we have to talk about Bohr's frequency rule. We have to talk about Bohr's frequency rule. So once again I will tell, don't worry. Bohr's frequency rule, if you are remembering first, you can write it here. If you are remembering about orbits afterwards, you can write it here. Their place can be anywhere. Okay? But only thing is minimum these many points should be there. Then we should talk about the equation where angular momentum of electron should be equal to n into h by 2 pi. N into h by 2 pi. Right? So that's what? Next point. Right? So we have got total 4 parts. Now in addition to this, you can tell about the properties of stationary states or energy level. So where you can mention about the equations. Where radius, if I want to talk about the radius, okay, so with respect to hydrogen atom, then it will be A naught into n square. Okay, A naught into n square divided by Z is not applicable for hydrogen because Z is equal to 1. Okay, so this is with respect to radius. Then only I am talking about hydrogen atom here. I am not talking about hydrogen like species. Then energy, if I want to talk about the energy for hydrogen for those energy level, then it will be minus RH, then it will be 1 by n square joule. So this is related to energy. So this is related to energy. Got my point? Okay, and at the end you can tell that velocity of the electron is directly proportional to atomic number. Then velocity of the electron in their respective energy level is inversely proportional to energy level. It is inversely proportional to energy level. Got my point? Okay, another point which we can mention here is about the principal quantum number. We can talk about the principal quantum number, right? So which is going to represent energy level will be represented with respect to principal quantum number. So these are the points. Those are the additional information. You can write it in the examination. Then at the end, what you have to write? At the end you should tell that yes, Bohr's atomic model is not only applicable for hydrogen atom, but it is also applicable for hydrogen-like species. So what do you mean by hydrogen-like species? Hydrogen-like species means these are the ions or atoms. Naturally it should be ions, it cannot be atoms. So these are the ions which will be having same number of electron as that of the hydrogen. So which is that? That will be helium plus, then it can be lithium plus 2, then it can be beryllium plus 3 or 3 plus, whatever it is. So lithium 2 plus or beryllium 3 plus, all these are examples for hydrogen-like species. All of you have understood? Any doubts in this? So this is with respect to hydrogen, this one, at Bohr's atomic model, which is also applicable for hydrogen-like species. Okay? So then we were solving the problems. If you remember, then we were solving the problems. And I told after solving the problem, we are going to discuss about limitations or drawbacks of Bohr's atomic model. Okay? Even that one they may ask separately. What are the limitations or drawbacks of Bohr's atomic model? Even that can be one of the question in your exam. Okay? But anyway, that one we will discuss it later. Before that, we will solve some of the concept and some of the problems. Any doubts? Yesterday I gave one problem as homework. Any one of you have done? Anyone tried to solve that one? Isoelectronic species, Rakesh, not spectra. Okay? So isoelectronic species. Okay, any one of you have tried? Anyone can tell me the answer? Shankar, not isoelectric, isoelectronic. Isoelectronic because iso means same, electrons. Number of electrons will be same. So therefore, isoelectronic. Okay. But they differs in their atomic number. Isoelectronic species, still they differs in their atomic number, no doubt. They cannot have same atomic number. Fine? Okay. So hagadre, anyone who has solved the yesterday's problem? Or otherwise shall we solve now? So what was the problem? Calculate the energy of 3 moles of photons of a radiation. 3 moles of photon of a radiation having frequency of 5 into 10 to the power of 15 hertz. 5 into 10 to the power of 15 hertz. Yeah. So this was the given information, right? Fine. So hagadre, what they have asked? They have asked about energy, E. They have asked about the E. So therefore, answer for this will be, please remember, for board exam you have to write given data or given information, then you have to write each steps involved during the calculation. Okay? So next one, H, normally they will give, don't worry, I have not written here. It will be 6.626 into 10 to the power of minus 34 joule second. 10 to the power of minus 34 joule second, that is Planck's constant. Okay, so that one they will only give. Next, they have asked about energy of 3 moles of photons. Energy of 3 moles of photons. So they have given the, okay, they have asked about energy. Now frequency they have given. Frequency is not energy. Frequency of 3 moles of photon is 3 moles of photon is 5 into 10 to the power of 15 hertz. Okay. So calculate the energy of 3 moles of photons of a radiation having, okay, this is not related to 3 moles. This is frequency of radiation. That's all. This is frequency of radiation is 5 into 10 to the power of 15 hertz. All of you have understood? Now we have to calculate first energy. So what is that? H is equal to nu. We have equation H is equal, E is equal to H into nu. Sorry, not H is equal to, it is E is equal to H into nu. Okay. Now H value we know, nu value we know. Therefore E is equal to 6.626 into 10 to the power of minus 34 joule second, okay, multiplied by 5 into 10 to the power of 15 per second. Hertz can be written in per second. So that's what I have written. Hertz can also be written as per second. Can also be written as per second. So therefore I have taken it as per second. All of you have understood? What is that answer you are going to get? What is that answer? So therefore E is equal to second will get cancelled because that is per second. So whatever answer comes, it will be having joule as its unit, because we are talking about energy. So unit should be joules or calories, whatever it might be. So answer will be 33.13 into 10 to the power of minus 19 joules. Minus 19 joules. So 33.13 into 10 to the power of minus 19 it should be. It cannot be plus. Right? Because it is minus 34. So 15 minus sign will be there. 33.13. Please remember. So you should be careful, Chidwan. Okay, anyone, not only Chidwan. So this minus should be written. 10 to the power of minus 19 joules. Now the problem here is that is for 1 photon. This energy is meant for the 1 photon. But they have asked about 3 moles of photon. They have asked about 3 moles of photon. This is for 1 photon. Whatever energy we have got, that is for 1 photon. They have asked about 3 moles. They have asked about 3 moles. We will see. Okay. Now, first what we will do is, we will calculate it for 1 mole first. We cannot multiply directly by 3. First we have to calculate it for 1 mole. Okay. Now how to do it for 1 mole? So for 1 mole of photon, it should be multiplied by Avogadro's number. E is equal to 33.13 into 10 to the power of minus 19 joule multiplied by, right? Multiplied by, what is that Avogadro's number? Anyone? What is that Avogadro's number? 6.022. 6.022. Right? So multiplied by 10 to the power of 23 multiplied by, so 10 to the power of 23. So that will be per mole. 10 to the power of 23 per mole. What my point? First we have to convert it for 1 mole. How much for 1 mole? This is for 1 photon. How much will be there for 1 mole of photon? It's a simple calculation. So for 1 photon, how much we have got? 33.13 into 10 to the power of minus 19 joule. How much for Avogadro's number of photons? Right? So that's what, divided by 1, I have not shown here, that's all. So that's where we have the calculation. So what will be the answer? Answer will be 199.5 into 10 to the power of 4 joule per mole. Joule per mole. Can you see here? Joule per mole. That is for 1 mole of photon. The answer is 199.5 into 10 to the power of 4. So whether this is the final answer? Anyone? Whether this one is the final answer? So what we have to do in next step? First you can tell whether it is the final answer, yes or no. Okay, all of you are absolutely correct. No, this is not the final answer. So before removing this, first I will explain what we have done. So they have asked about calculate the energy of 3 moles of photons of a radiation having frequency of 5 into 10 to the power of 15 hertz. Now what we have done, by the information of Planck's constant, by using E is equal to h nu, we have substituted those values and we have got the value of energy. So whatever value we are going to get, that is for 1 photon. That is for 1 photon. Yes, all of you have right. We have to multiply it by 3. Yes. So this energy, whatever we have got, it is for 1 photon. So we have to convert it into 1 mole of photon. First, instead of directly multiplying this one by 3. Because if we multiply this one by 3, it will be for 3 photons. But we don't want 3. We want for 3 moles of photon. So first we have to convert for 1 mole. So we have got the answer as this one. How we have got 1 mole? By multiplying the value with Avogadro's number. Why with Avogadro's number? Because Avogadro's number of anything is nothing but 1 mole of that particular substance. So 1 mole of photon is nothing but this many number of photons should be there. Okay? So yes, it should be 5985. Yes. So this is for 1 mole of photon. If you have understood, we'll move to the next one. Okay, so the final answer or final step, it will be, we have to multiply whatever answer we have got for 1 mole by 3. So therefore, for 3 moles of photon, for 3 moles of photons, so for 1 mole of photon, how much we have got? We have got 199.5 into 10 to the power of 4 joules per mole. Right? So in that case, how much for 3 moles of photon? So mole and mole will get cancelled. So the final answer will be having joule as the unit or kilojoules per 3 moles. You can write that one. So it will be 598.5 into 10 to the power of 4 joules. That is for 3 moles. 598.5 into 10 to the power of 4 joules. All of you have understood? Now, instead of writing in terms of joules, can we convert that one into kilojoules? Here only I am teaching conversion also. Please remember. Can you convert joules into kilojoules? What will be the answer? If I want to write in terms of kilojoules, how to convert? Whatever answer we have got, it is in joules per 3 moles. That is for 3 moles. So how to convert that one into kilojoules per 3 moles? 0.5985. Okay. So yes. Say for example, this is in terms of joules. So now we have information that 1000 joules will be equal to 1 kilojoules. 1000 more joules is nothing but 1 kilojoule. So therefore, for 1000 joules, it is 1 kilojoules. How much will be for 598.5 into 10 to the power of 4 joules corresponds to how much will be? Yes, Savita, you are right. 10 to the power of 4 you can keep as it is, or you can remove 3 zeros and here, right? So therefore it will become 598.5 into 10 kilojoules, or simply we can write it as 5985 kilojoules. 5985 kilojoules. All of you have understood? So 10 to the power of 4 is there. So I have removed that zeros, I have removed with 3 zeros at the bottom. So that's why we are going to get the 5985 kilojoules. Fine, all of you have understood? If you don't want to disturb this one, then you can keep it. It will come in decimals. It will come in decimals. Okay? So this is how we should calculate. Any doubts in this? Hmm? Any doubts? Please remember, for board exam on frequency, wavelength and all, small problems they will ask for 2 marks and all. But for competitive exams also you can expect the problems on this. Okay? So any doubts? All of you have understood whatever we have solved just now? Any doubts in any of these steps? So first what we have done? We have calculated it for 1 photon. What is the amount of energy? Then we have converted that one into, or we have calculated that one for 1 mole. And finally, we have calculated it for 3 moles by multiplying it by 3. Whatever answer we have got. Shall we solve another one? Okay. So now, calculate the number of photons emitted per second. It should be emitted per second. Emitted per second by a bulb of 100 watts, emitting light of wavelength 500 nanometer. Emitting light of wavelength 500 nanometer. Similar problem is there in your textbook also. So calculate the number of photons emitted per second by a bulb of 100 watts. Okay? So it is compulsory to convert it into, no, Rohan. No, it's not compulsory. Okay, I will make a statement here. Yes, it's natural question. Okay, I will tell here. It's not compulsory. You have to convert joule into kilojoules. So therefore, while converting that one, I told. Here I want to teach you conversion. Okay. So by chance in the competitive exam, if they have given the options in terms of kilojoules, then you should know how to convert joules into kilojoules. So for that purpose, I have written. Okay. Please remember in your board exam, if you are writing in terms of joule or kilojoules, whatever it might be, answer matters. Okay, whether it is in joule or whether it is in kilojoules. Okay, so conversion is not compulsory. Okay, for all of you. This point I will make it clear. Okay, it's not compulsory. Now, this is where we have next question. So calculate the number of photons emitted per second by a bulb of 100 watts emitting light of wavelength 500 nanometer. Okay, so 500 nanometer. So first thing, what do you mean by watts? Because it's the derived unit, it's not SI unit. Watts are not the SI unit. So that is related to power of the bulb. That is related to power of the bulb, which is nothing but 100 watts. That's what they have given. Now, if I want to convert that one into SI unit, please remember you have to convert that one into SI unit only. So it will be 100 joule per second. It will be 100 joule per second. Watts is a derived unit. Watt is a derived unit. Yes, unit of power. So in case of SI unit, it will become joule per second. It will become joules per second. So value will not change. It will remain 100 only. Okay, it will remain 100 only. So that is one statement. Now, what they have given? Nanometer. So wavelength of the radiation or light. Okay, I will use the word light on. Wavelength of the light wavelength of the light is, they have given 500 nanometer. 500 nanometer. We can convert that one into meter. We can convert that one into meter. Please remember, 1 nanometer is equal to 10 to the power of minus 9 meter. This one you should know. So 1 nanometer is equal to 10 to the power of minus 9 meter. Such a small unit. Very, very small unit. So therefore, nanometer, angstrom unit, picometer. So these are the some of the small forms of the meters. For example, size of the atom or size of a living cell. These will be expressed in terms of angstrom unit or nanometer or picometer. They cannot be expressed in terms of meter. They have to convert it into smaller values. So nanometer is derived from meter only. So that's how it can be convertible. So nanometer, nano, that means 10 to the power of 9. That's where nanometer, it's a small. Meter is a large one. So therefore 1 nanometer is equal to 10 to the power of minus 9 meter. Not 9, it is minus 9 meter. Okay? So that's what we can write. So therefore it can be written as 500. All of you have understood? It can be converted into, why I am converting that one in meter, you will come to know. Now I will tell, yes, this conversion is very much required. Now as I have told, whether joule can be converted into kilojoules or not, that one we got the answer. It's not compulsory. But here, nanometer to meter, it is compulsory. Nanometer to meter, 1, 2, 3, 4, 5, 6. No, still some zeros are missing, Rohan. Okay? So it is 10 to the power of minus 9. So now, so here this conversion is very much required. Why? You will come to know. Because we know the equation that E is equal to H nu. All of you will agree? E is equal to H nu. Then we know that nu is equal to C by lambda. Nu is equal to C by lambda. All of you will agree? E is equal to H nu, that is one equation. Nu is equal to C by lambda, that is another equation. So therefore, E is equal to H into C by lambda. All of you will agree? Because wavelength they have given. Since wavelength they have given, by using this one we cannot calculate the energy. We have to go with this equation. Okay? So where we have substituted the relation between frequency and wavelength. This value we have substituted here. So therefore E is equal to H into C by lambda. So what is C? Speed of light. That is meter per second. That's where meter is coming. So therefore nanometer I am converting that one into meter. So that while calculating, please remember, while calculating all the units should be in same format. Means all the values should have same units. Number of photons. Okay, we will see. So that's where we have the equation. Okay. Now H value they will give, don't worry. Therefore E is equal to 6.626 into 10 to the power of minus 34 joule second into speed of light, that is 3 into 10 to the power of 8 meter per second, divided by, what is that, lambda? Lambda is 500 into 10 to the power of minus 9 meter. All of you have understood? So I have substituted H, I have substituted speed of light value, and I have substituted wavelength, whatever they have given, wavelength of the light. Now you can observe here, meter, meter. Otherwise if I keep it in nanometer, it will be wrong. So it should be meter and meter. So they will get cancelled. Okay. even seconds, and per second it will get cancelled. So whatever answer comes, it will be in terms of joule, because we are talking about energy. So what is that value you are going to get? Anyone? What is that value? So now you came to know why we have converted nanometer into meter. That is because we have got speed of light here. So which will be expressed in terms of meter per second. So to have the meter. So therefore we have converted nanometer into meter. This is compulsory. This conversion is compulsory. Okay. Now what is that value? 3.97. Okay. Yes, you are right. Okay, it will be, or whatever answer comes, I will write as it is to avoid the confusion. 0.0397 into 10 to the power of minus 17 joule into 10 to the power of minus 17 joules. Okay. So what is this value? This value is meant for the 1 photon. So this value is meant for the energy of 1 photon. As we have discussed in the earlier, this is meant for the energy of 1 photon. All of you have understood? Now we can calculate what is the number of photon. How? By using this information. By using watts, we can calculate what will be total number of photons. How to calculate? So that is for one photon, energy is 0.0397 into 10 to the power of 17 minus 17 joule. Right? So that is meant for 1 photon energy. Okay? So therefore that is for 1 photon, that energy. Now I will remove this. So that is for this energy, whatever we have got, that is for 1 photon. So how much will be there? How much will be there in 100 joules per second? Yes, per second. So therefore watt we have converted into joule per second. This is the reason. So joule per second. Fine. Now what will happen? So joules and joules will get cancelled. So whatever answer comes, it will be in per second. So therefore we can write it as 2518.89 into 10 to the power of 17 per second. Per second, or you can convert that one into hertz, whatever it is. Calculate the number of photons emitted per second. They have asked per second, right? That is frequency. Number of photons emitted per second by a bulb of 100 watts emitting light of wavelength 500 nanometer. So that's what we have got the answer. This will be the number of photons, because for so many energy it corresponds to 1 photon. For this many energy per second, how many photons will be there? So that's what, that will be number of photons per second. To be more appropriate, I will write number of photons per second. Okay, so all of you have understood? Any doubts? So this can be the final answer. This can be the final answer. Any doubt? So once again I will explain. Calculate the number of photons emitted per second. They are talking about frequency by a bulb of 100 watts emitting light of wavelength 500 nanometer. Now since we are going to use this equation, E is equal to h nu Further, since nu is equal to C by lambda, we have got the equation as E is equal to H into C by lambda. Right? So why we are using this equation? That is because they have given the wavelength. They have given the wavelength. So therefore we are using this particular equation. Now H value we know, C that is speed of light we know, wavelength they have given. So we are going to get the energy of one photon by using this equation. Now before using this equation, whatever wavelength they have given, we have to convert that one into meters because it is in nanometer. So we have to convert that one into meters. Okay? So that's where we have got 500 into 10 to the power of minus 9 meters. So by calculating this one, we have got the energy of one photon. Now next we have to calculate what will be number of photons in this particular energy which will be per second. So therefore, this many energy corresponds to one photon. So this many energy per second corresponds to how many photons? So these are the number of photons per second. That's what we have got the value. And please remember, everywhere unit, especially for final answer, unit is compulsory. For a final answer, unit is compulsory. To have the proper unit at the final value, while calculating only you should apply the appropriate unit. Then there will not be any errors in putting the unit for the final answer. Okay? Any doubts? Shall we move to the next one? We will solve some of the problems related to hydrogen spectrum. We will solve some of the problems related to hydrogen spectrum. Still time is there. Okay? Some more problems we will solve. And please, you can practice some more problems from your check sheet also. Okay? So you should practice, you should take some more problems from your check sheet and textbook related to frequency, wavelength and energy. Okay? So hagadre we will solve some problems on hydrogen spectrum equation. What are the frequency? What are the frequency and wavelength? Frequency and wavelength of a photon. Absorbed of a photons absorbed during the transition of electron from second energy level to fifth energy level. Second energy level to fifth energy level. Okay? All of you have understood? Now they can extend the question and name the series to which it belongs to. And name the series, spectral series it belongs to. Okay na? So that's where we have the question. So what is that? What are the frequency and wavelength of a photons absorbed during the transition of electron from second energy level to fifth energy level, and name the series it belongs to? Yes, it should be Bohrs series, because from second energy level they are talking about. So it should be a Bohrs series. Definitely. Okay, it should be a Bohrs series. So answer, it belongs to it belongs to Bohrs series. So in electromagnetic spectrum, this is nothing but visible region. Bohrs series, that is nothing but visible region. All of you will agree that is nothing but visible region. Okay. So whatever answer will be there, it should be in visible region. So that's what we have got the information based on whatever information they have given. Next, we have to apply the equation now. So delta E is equal to RH. Don't worry, RH value they will give. RH 1 by Ni square minus 1 by Nf square joule. Or otherwise, if you solve 3-4 problems, it will be by hearted, like Planck's constant, Rydberg's constant, everything will be by hearted. If you by hearted in the sense, automatically, when you solve 3-4 problems, you will be knowing the value. So therefore, delta E is equal to 2.18 into 10 to the power of minus 18 joule, that is nothing but RH value, multiplied by what is Ni? Ni is second energy level. From second energy level, it is moving to the fifth. So initial energy level is second energy level. So 1 by 2 square minus 1 by 5 square. Joule I have written here only, therefore at the end I am not writing the joules. Okay. So by substituting the value, because transition will happen from second energy level. From, that means second energy level will be the initial energy level and final energy level will be fifth energy level. So that's what Nf value will be 5 square, Ni square value will be 2 square. So that's what I have written. So therefore, delta E is equal to 2.18 into 10 to the power of minus 18 joules multiplied by 1 by 4 minus 1 by 25. 1 by 4 minus 1 by 25. So further, 2.18 into 10 to the power of minus 18 joule multiplied by 0.25 minus 0.04. 0.25 minus 0.04. So that will give 2.18 into 10 to the power of minus 18 joule multiplied by 0.21. 0.21. It will have the positive value. It will have the positive value. Okay, 0.21. Because we are talking about absorption. Okay, na? So that's where we have the delta E. So finally we can write it as further solve. If we solve further, we will get the value as 0.457 into 10 to the power of minus 18 joule. All of you have got 0.457 into 10 to the power of minus 18 joule. So it should be positive value. You can cross check your answer. Since it is from second energy level to higher energy level, that's why it is an absorption spectrum. And for absorption, energy will be positive. Please remember, that's what you should cross check in between. So whatever value you should get, it should be a positive value. It cannot be a negative value. Only for emission, it will be a negative value. Here, since it is absorption, it should be a positive value. All of you have got? Now, we have to find frequency. We have to find the frequency. We have got the energy. Now we have to find the frequency. Which equation we can use? Anyone? Now we have got the energy. Now we have to find the frequency. Which equation we can use? You can just type the equation. Anyone? Please, if you are not understanding, let me know. Okay, so we have found the energy. Now we have to find the frequency and wavelength. First we will find the frequency. What is that equation? RH by H. Stephen, why RH by H? Which equation we have to find? We have to use the equation E is equal to H nu. E is equal to H nu. Nu we have got, means E we have got. We have to find the nu. Yes, Likita, it is E is equal to H nu. So therefore, nu is equal to H E by H. Nu is equal to E by H. Right? So we have got the E value just now. So therefore, nu is equal to 0.457 into 10 to the power of minus 18 joule divided by 6.626 into 10 to the power of minus 34 into 10 to the power of minus 34 joule second. Joule second. So naturally, this is Planck's constant value. So joules will get cancelled. Whatever answer comes will be in terms of per second, because we are talking about frequency. So what is that value? That will be 0.0689 into 10 to the power of 16 per second. Into 10 to the power of 16 per second. We have got the frequency. One answer we have got. Already we have known. Name the series it belongs to. Already we have mentioned it belongs to Bohrs series, that is visible range. Okay. Then we have calculated the frequency also. So what is left over? Left over is wavelength. All of you are understanding? Okay. So all of you are understanding, right? So since we have got the energy, since we have to find the frequency, instead of wavelength, first we will find the frequency. E is equal to H nu is the equation. By rearranging this, nu is equal to E by H. So that's where this Planck's constant we have substituted, and whatever energy value we have got it, then we have got that one also we have substituted. So the answer will be frequency per second. Okay. Now next step will be finding the wavelength. Next step will be, that will be the final step. Next step will be finding the wavelength. Okay. Someone, can you tell me which equation we can use to find the wavelength? Which equation we can use to find the wavelength? We have got the energy, we have got the frequency, now we have to find the wavelength. And based on the wavelength, we can tell whether it is visible spectrum or not, to confirm the answer. C divided by lambda. Okay, but we have to find lambda, na? Right? Yes, we have to use the equation nu is equal to C by lambda by rearranging this, because we have to find the lambda value. So therefore lambda is equal to C by frequency. C by frequency. Okay? No, don't go for wave number. Okay, Chitwan. Okay, fine. So lambda is equal to C by nu. C by nu. Yes, Rohan. C by nu. Now we know the value of C, that is 3 into 10 to the power of 8 meter per second. Right? Then we have the, we have got the value of frequency as 0.0689 into 10 to the power of 16, right, per second. 10 to the power of 16 per second. So per second will get cancelled. Whatever answer comes, it will be in terms of meter. That's what the unit for wavelength, right? So the answer will be 43.54 into 10 to the power of minus 8 meter. This can be your final answer. 43.54 into 10 to the power of minus 8 meter. Now, once again I will tell, this will be your final answer. This will be your final answer. So whatever I am writing next, that will be extra information for the conversions, which can help you in your competitive exams. Say for example, when I am talking about nanometer, whenever we are talking about wavelength, it will be expressed in terms of nanometer because of smaller length. So instead of meter, they will go for smaller unit of meter, that is nanometer. So therefore, we know that 10 to the power of minus 9 meter is equal to 1 nanometer. So 10 to the power of minus 9 meter is equal to 1 nanometer. Right? So that information we know. So therefore, we can convert this one. So for 10 to the power of minus 9 meter, it is 1 nanometer. How much will be for 43.54 into 10 to the power of minus 8 meter? It corresponds to how many nanometer? Meter will get cancelled. The answer will be in terms of nanometer. How much it will be? If I am right, it will be 43.54 into 10. Or we can simply write it as 435.4 nanometer, which is visible range, which is nothing but visible range. So whatever we have calculated is absolutely correct. That's how you should cross check your answer. Please remember. Now, when it comes to electromagnetic spectra, remember it properly. Anything below 280 or 300, anything below 280 to 300, that will be considered as UV. Anything above 280 or 300, normally even 350, anything above 350 will be considered as visible. Whether I am clear? So anything below 280 or 300, so that will be considered as UV. And anything above 350, 300 or 350 above, it is called as visible. So we have got 435.4 nanometers. So that means it is in visible range. So whatever we have got the answer, it is correct. Right? Because we have given the information that it belongs to Bohrs series. And Bohrs series in electromagnetic spectra, it belongs to visible range. If you go back to that table which I have given, you will get the answer. Okay? Any doubts in this? Okay? So you can solve some more problems on hydrogen spectra. Tomorrow we will solve another 1 or 2 problems. Okay, even you can practice some more problems. Any doubts? Whatever we have solved in this, what you can do today here is, today you can practice more problems on frequency, wavelength. On those you can practice more problems from your check sheet and textbook. Fine? Any doubts? So in that case, I will stop here. Take care. Okay? So take care. Thank you. Thank you. Thank you very much.